Check it.
Okay, welcome back. Today we're going to be talking about square root inequalities and domains of functions, two things in one. Square root inequalities, graphing them is just like graphing square root functions, which is what we did in the last lesson. The only thing is they're inequalities now. So instead of it being y equals the square root of x plus 3, it's y is less than. And if you remember when we did inequalities earlier in the year, the inequalities added two more details to your graph. One was, is the function solid or dotted? And the second thing is, do you shade up or do you shade down from the function? Okay, that's it. So we're going to be doing what we did before, but we're just going to be adding those extra two dimensions to the situation. So let's get started. Now, in the other lesson, we started off by finding the domain of the function because the domain told us where to start our table. So that has not changed. We're still going to find the domain by taking the integrand, the argument of the square root here, and setting it greater than or equal to 0 in order to find the domain. So we're going to do that. Let's subtract 3 from both sides, and we get x is greater than or equal to negative 3. Now, how do you write your domain? You write your domain as all real numbers such that, that's what the two dots there mean, the colon there, x is greater than or equal to negative 3. So there's your domain right. And from that, you can make a table. X comma, whatever the name of the function is, f of x, or in this case, y. We're going to start our x's at negative 3, because that's the starting point. That's got to be a good point. That's always going to work. And then we'll just go by ones until we fill in the graph here. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. The important thing is that we get 4 good, I call them, well, they're called lattice points, or 4 good graphable points. Now the lattice points are the ones that have no decimals in them. If we can get 4 lattice points, that's the ideal situation. But if we can't get 4 lattice points, we'll take out our calculator and just find a couple extra points until we have 4. All right, so here we go. Negative 3. If you plug a negative 3 in here, you get negative 3 plus 3, which is 0. Square root of 0 is still 0. So there's the first point. The first point's got to work because you chose it that way. The second point, let's see if that works. Negative 2. Negative 2 plus 3 is 1. Square root of 1 is 1. So that worked pretty well. We got 2 good lattice points here. Negative 1. Well, negative 1 plus 3 is 2, and you can't square root 2 without getting a decimal, so let's skip that one for now. 0. 0 plus 3 is 3, and 3 is not a perfect square, so you'll get a decimal if you try to square root it. Let's skip that one. 1. 1 plus 3 is 4, and the square root of 4 is 2, so that is a lattice point. So we got 3. We just need one more now. One more, and we can stop plugging numbers in. 2. 2 plus 3 is 5, not square rootable without getting a decimal. 3 is square root of 6, no good. 4 is square root of 7, no good. 5 is square root of 8, no good. 6, well, 6 plus 3 is 9. 9 is a perfect square, so you can square root it, and you get 3. So there you go. And we have our 4 good lattice points there. We don't have to reach for a calculator at all. Okay, we got no decimals, so nice and easy. Now let's graph these. Negative 3 comma 0, negative 1, negative, you know what, let me make these points, this graph a little bit bigger so you can see the details better. Negative 3 comma 0, I'll exaggerate the size here so you can see it well on the screen there. Negative 2 comma 1, negative 2 comma 1, that's right here. 1 comma 2, well 1 comma 2 is here. And 6 comma 3, 1, 2, 3, 4, 5, 6. Comma 1, 2, 3, that would be here. So we started at negative 3 and we ended here at positive 6. 4 points is good enough, so we won't have to plug in anything else. Now, before I draw my function would normally just be this thing right here, right? And if we were doing equations, if this was y equals the square root of 3, whatever, x plus 3, then we'd be done already. But this is an inequality. So we have to ask the question, is this solid or dotted? And if you remember from the linear inequalities we did earlier in the year, if your inequality is underlined, meaning less than or equal to, or if it was greater than or equal to, if we had that underline there, then it's solid. But if it's not underlined, it's dotted. So this is not underlined, so this is not going to be a solid function, it's going to be a dotted function. So your job is to now draw a dotted, or dashed if you want to be literal about it, a dashed function, dotted function, because this is not equal to. It's just less than but not equal to. Now we have to decide, do we shade above or shade below? Now let me be clear about something. You have to obey the domain when you do your shading. So some people say, all right, you're shading above, I'll shade above like this, and then they'll get it wrong and they'll go, why did I get it wrong? I shaded above. Because everything here, okay, is not supposed to be in the domain. All right, all this is violating the domain. So the domain says you cannot be less than -3. You have to be all real numbers, meaning any number in the universe, as long as it's greater than or equal to -3 for your x. So you cannot be anywhere that's to the left of -3. So be careful. Wherever you end up shading, make sure you do not pass this line right here. Okay, I'm doing my best to trace it with my tablet here, but okay, so this line right here is the wall. You can't pass that. So when you go to shade, if you end up shading outside of that, you're wrong. So I recommend that you shade very deliberately and very intentionally and neatly, and make sure you do not pass that line and do not touch the function. So anyway, the question now is, do we shade above or below? The way we decided to shade above or below is to test the point. Now you could look at the less than or the greater than here, the inequality, and take a guess, but the inequality sometimes does not tell you the right thing to do. So rather than tell you what works most of the time, we have to teach you the right way to think. The right thing to do here is to teach you what works all of the time. And depending on where the negatives are in an inequality, the inequality symbol might lead you astray. So we're going to test a point. Now the way to test a point, you have to obey certain rules, and we talked about these earlier in the year, but I'll reiterate them here. First of all, you must be not on the function. So you need to test a point that's not on the function. Second, because there's a domain to think about here, must be in domain. Like I was saying before, you can't test a point over here because that's outside of the domain. The domain starts here and is this way, right? That's the domain, and you cannot be to the left of -3. Now the third one isn't a requirement, but it's a convenience, okay? The third one is choose, well, I'm going to say the simplest numbers to plug in to make your life easier. And the simplest number to plug into any function for this purpose is 0. So choose points with zeros in it. The more zeros, the better. And that's not a requirement, but that is going to make your life easier. Okay, so let's go ahead and choose a point that satisfies all these criteria here. So we cannot choose, for instance, -3, 0, because that's on the function. And we cannot choose whatever this point is, all right? And we cannot choose -2, 1, because that's on the function. So don't choose anything on the function. And don't choose anything that's too close to the function either. For instance, I wouldn't choose this point right here because it's too darn close, and if your handwriting is a little bit off, you might actually be, you need to be able to tell clearly if you're above or below the function. Now I know that my thing is nice and neat here and it looks like I'm definitely below it with my circle, but what if this was sloppy and actually this function was below it and not above it? So give yourself a little wiggle room here. When I say not on the function, I also mean not too close to it either. So the last thing is, you're in the domain, you're not on the function. The last thing is choose something with zeros in it. So the points with zeros in them are either on the y-axis, because there's something, 0, or on the x-axis. Sorry, the y-axis is 0, something, and the x-axis is something, 0. So the best point to test would be 0, 0. If 0, 0 is both not on the function and not near the function, which it's not, and in the domain, which it is, then I would go with 0, 0. But let's say, for instance, your function is going through 0, 0. You couldn't choose that. So then choose like 1, 0, or -1, 0, or 2, 0. Anything that satisfies these conditions and has some zeros in it would be good. So in this case, 0, 0 would do the trick. So plug in the coordinates here are 0, 0, which means your x is 0 and your y is 0. Plug in 0 for y, plug in 0 for x, and see if your statement is true or false. So we get 0 for y is less than the square root of 0 for x plus 3. When you simplify that, you get 0 is less than the square root of 3. Now, the square root of 3 is a positive number. Is 0 less than a positive number? Yes, that's the definition of 0. A positive number, a positive number is anything greater than 0, so 0 has to be less than it. You know, this is like 1.7 something, so 0 is definitely less than that. That's true. And like we learned with the linear inequalities, if it's true, you shade towards this, the test point. The test point is below the function, and you tested below the function and it's true, so you shade down from here. So we're going to shade down, but be careful when you're shading down, don't violate the domain. Don't be sloppy and shade like this and then lose all your points, because that, And also, don't be this person. Some people will shade only to the x-axis. Now that's totally wrong too, because what about all this stuff down here? That's also part of the answer. So be careful. You want to shade to the edge of the graph, but you don't want to violate the domain, and you do want to shade down. So my advice is be vertical with your shading and neat. Okay, you don't like literally shade, like scribble in. Just put these vertical lines here, and then when you get to this one here, be very deliberate, very careful, because you don't want to cross. You know what I'm saying? I'm trying to hit it with my tablet here. All right, and there you go. And you just want to, and also don't, by the way, don't cross this either, because that also violates, right? So be careful not to cross the function or touch the function. All right, and there you go. That's your shaded region for the first example. Okay, the second example here, we're going to do the same thing. We're going to find the domain of the square root before we do anything else. So the domain is what we get when we take 5x plus 2 and set it greater than or equal to 0, right? So we'll solve that. We'll subtract 2 from both sides. We get 5x greater than or equal to negative 2. And then we're going to divide both sides by 5. We're going to get x is less than or equal, greater than or equal to negative 2/5. Now in decimal, that's negative 0.4. The only reason why I'm bringing up the decimal is because we're going to be graphing it, and so, you know, when you're graphing, it's good to know what the decimal is. So we're going to start our table at negative 2/5. And now the question is, well, what do we do with the rest of our table? Well, to keep things simple, we're just going to go to the next, we're just going to use whole numbers from after that, okay? Because otherwise it's going to be a nightmare. So negative 2/5, what's the next highest whole number? Well, it's negative 0.4, which is like there. The next whole number would be 0. And then 1, 2, 3, 4, 5, 6, 7, 8. And my graph only goes to 9 here, so I'll just stop at 9. All right, now the first number is guaranteed to work because we chose it. By the way, this is all real numbers, such that that's your domain right there. It's not my final answer, so I'm not going to box it, but there it is. That's the domain. And this is guaranteed to work because we chose it like that. So let's see, negative 2/5, if you put it in here, right, 5 times negative 2/5, the 5's cancel out. This just becomes negative 2. And negative 2 plus 2 is 0. And the square root of 0 is still 0. And negative the square root of 0, negative 0 is still 0. So this whole thing just becomes a 0 plus 2 is 2. So that point works, and it has to work. Otherwise, why did you choose it? Now we'll plug in the rest of these. Plug in the 0. 5 times 0 is 0, and 0 plus 2 is 2. You can't square root 2 without getting a decimal, so we'll skip it for now. Plug in a 1. 5 times 1 is 5, plus 2 is 7. That's not going to work. Plug in a 3. 5 times 3 is 15, plus 2 is 17. Not a perfect square. 5 times 4 is 20, plus 2 is 22. Not a perfect square. 5 times 5 is 25, plus 2 is 27. Plug in a 6. That's going to be 32. Plug in a 7. That's going to be 35, plus 2 is 37. Plug in an 8. That's 42. Plug in a 9. That's 47. None of these numbers give you a whole number. None of these numbers give you a perfect square. So we're in trouble here. We're supposed to get 4 points, right? We need 4 points. I'm not going to accept less than 4 points, and you don't have 4 points. So this is when you're going to have to just, you don't have a choice. You're going to need to find 3 more points with your calculator. So let's say you found, just for argument's sake, you found 2 lattice points. Like you found one here, and you found, I'm just going to make up a number here. You found 1 here. You're still going to need 2 more, and you'll break out your calculator to find the 2 more. Or let's say you had 3, right? Let's say this for some reason worked, and this for some reason worked. You'll just have to find 1 more with your calculator. But in this case, kind of an extreme case, we only got the 1 guaranteed one, and we have nothing here. So we're going to have to grab our calculator and just do some with decimal. Okay? Now we only need 4 lattice points. Okay? So you know what? Let's do, since we're going this way on the graph, let's do the last one. Let's do 9, and we have the first one. Let's just do 2 more in the middle here. Let's do, 3 and 6. So we'll do 3, 6, and 9 with the calculator. And that'll give us 4 points that we can use. Unfortunately, we have to break out a calculator for these 3 because there's no way to do them without using decimals. Okay. So the function is negative square root of 5x, so 5 parentheses. Now the first x I'm going to use is 3, close parentheses, plus 2 inside the radical. And then I'm going to use the arrows to get out of the radical and put another plus 2 outside the radical. So hopefully that looks exactly like this. Hit enter, and I'm getting negative, I'm going to just round it to the nearest hundredth, it's negative 2.12. Now I want to do 6. So I'll just bring back, press the up arrow on your regular calculator or press second enter on your graphing calculator. and change this to a 6. So we get negative 3.66. All right, and the last one is 9. So let's plug in a 9 where the 6 is here. And we get negative 4.855, so negative 4.89. And that's it for the calculator. So we have our 4 points now. We can start making our graph. Negative 2/5, once again, is negative 0.4. So a little bit less than negative a half, like right about there, and then up 2. So that would be right about there. 3 comma negative 2.12. So 1, 2, 3, and then down 2.1 is like right about there. Now this is not going to be perfect because it's all decimal approximation, but we'll just do our best. 6 comma negative 3.66. So that's 3, 4, 5, 6, and then down 1, 2, 3 point, almost 0.7. So like roughly there. And then finally 9, which is the last number here, and negative 4.89 or 4.9. Negative 1, 2, 3, 4, and almost, well, that 1, 2, 3, 4, and then almost 4.9, like almost 5, like right there. So hopefully you can see the shape there. There it is. Now, before you draw your function, look over here. It's underlined, so this is going to be solid. If it's not underlined, it's dotted. So this is a solid function, and just do your best to make it look like a sideways parabola. Well, just the lower half of a sideways parabola, and all the way to the edge of the graph. So you can see why I chose the last point as one of the points, because I want to, I want to go to the end of the graph there. All right, now do we shade above or below? Now, once again, the requirements for shading, testing a point for shading is that you're not in the function, you're in the domain. So I can't choose, and I don't want to be too close to the function either. So I wouldn't choose this point here because it's a little bit too close. And I definitely wouldn't choose this point here because that looks like it might be on the function or very close to it. So something that's not too close to the function, you know what? 0, 0 worked last time, but it's a little bit too close for comfort here. So I'm not going to use it. And like I said, this one's also too close for comfort. I'm going to go to this one here. So what is this? This is 2 comma 0, and it's above the function. So if I test this and it's true, I'm going to shade up. If I test this and it's false, I'm going to shade down. So x is 2, y is 0. Let's see what we get. If y is 0, this is going to be 0. Okay, less than or equal to negative 5 times, and we said x is 2, plus 2 inside the radical, and then plus 2 outside the radical. So let's simplify that as much as possible now. This is going to be 5 times 2 is 10, plus 2 is 12. And then plus 2. So if you're not sure, I mean, okay, if I think about this, the square root of 12 is going to be more than 3 because the square root of 9 is 3. So this is like negative 3 point something plus 2. It's got to be a negative number. But if you're not, if you're not sure about it, just take your calculator, plug it into the calculator. So you have negative the square root of 12, like I said, negative 3 point something plus 2, and you get negative 1.46. So 0 less than or equal to negative 1.46. Now, is it true that a 0 is less than a negative number? No. 0 is greater than a negative number. That's negative numbers are less than 0. That's why they're negative. So this is false. This isn't true. So since this is false, you're not going to shade up towards the test point. You're going to shade down away from the test point. So you're going to shade this way. So once again, be neat. Don't touch the function or cross the function. All right. And when you get to that domain edge right there, be careful. Okay, negative 0.4, you're not going to pass that. So just do your best to not pass that right there. Get as close as you can to the function without touching it, and we are done with this. Okay, the next section here is going to be domains of functions. We're just going to touch upon this briefly. There are 3 things you need to look out for when you're looking for the domain of a function. When we ask you for the domain of a function, you have to make sure the function does not have a 0 denominator anywhere, does not have a negative inside of a square root, and later on in the year that you don't have a negative or 0 inside of a logarithm. But that's later this year, so we're not going to talk about that. Now, the negative inside of a square root we've been doing for this lesson for the last couple of lessons. So we already know how to do this one fine. The question is, what about 0 denominators? So I'm going to give you a mix of these two, and you're going to have to decide. All right. So let's come down here. Okay. So once again, the 2 things we're looking out for here, the 2 major things we're looking out for here are 0 denominators or a negative inside of a square root or both. Those are the 2 red flags. Later on, it'll be the 3 red flags when we learn logarithms. But for the time being, it's just these 2 things that we're looking out for. And let's see. Is there any way that this function here could have a 0 denominator? Well, it definitely has a denominator, so we need to check for this situation. Does this also have a square root? No. So there's no chance of having the square root issue, but there is a chance of having the denominator issue. Now, how do you check for the denominator issue? You take the denominator and you set it equal to 0 and you solve. Okay? So here we go. Set this equal to 0. What would cause this denominator to equal 0? Well, when you solve, you'll find out. Let's get the x by itself, and there it is. X equals 5. What this is telling me that is, if x equaled 5, if I were to plug a 5 in here for x, then this would create a 0 denominator. Let's see. 5 minus 5 is 0. Yeah, that creates a problem. So what's my domain? Well, here's how you do this. You start with the assumption that the domain is all real numbers, that double R. And then you check for your 3 red flags. Like I said, there's only 2 of them right now. You check for your exceptions, all right? And you remove whatever troublesome numbers there are from all real numbers. So we're going to start with the domain being all real numbers, double R, such that this is not included. So we'll say such that x is not equal to 5, and there's your domain. All real numbers except x equals 5, or all real numbers such that x is not equal to 5. That's your domain, okay? And that's what we need there. All right, how about this one down here? Now this function down here, is there any possibility that it can have a 0 denominator? Well, there's no denominator, right? It's not even a fraction. Okay, it's not a rational function. There's no denominator, so there's no chance that you can have a 0 denominator, so don't worry about it. Is there a chance of having a negative inside of a square root? Well, do you see a square root here? No. So there's no chance of either one of these things happening, and there's also no logarithm, so it's just all real numbers, right? You start with all real numbers, and then you look for these exceptions. Since there's no exception, there's nothing to worry about here. Okay, let's move on to this next one here. Okay, let me just paste the requirements over here. Is there a chance that you have a 0 denominator? Well, there's a chance because there is a denominator. Is there a chance of a negative square root? No. So we're only looking for 0 denominators. So the way you, once again, for the denominator, what you do is you set the denominator equal to 0 and you solve. So we go x squared minus 9 equals 0. You can add 9 to both sides. You get x squared equals 9. You can square root both sides. The square root of x squared is absolute value of x, and the square root of 9 is 3. Okay, the principal root. And then when you take the absolute value of this, you get x equals plus or minus 3. So you get 2 answers here. That tells me that if I plug in a 3 here, that I should get a 0 denominator. Let's see if that's true. 3 squared is 9, and 9 minus 9 is 0. Yeah, that works. And I should also get a 0 if I plug in negative 3. Well, negative 3 squared is also 9, and 9 minus 9 is still 0. So yeah, okay? And by the way, if you're thinking to yourself, hey, couldn't he have factored this? Yeah, if I factored it as a difference of squares, I would have gotten x plus 3, x minus 3 equals 0, and that would have given me the same answer. So yes, if you're eagle-eyed and you picked up on the difference of squares there, that would also work. So what's my domain? It's all real numbers such that x cannot equal 3 and x cannot equal negative 3, and there it is. Okay, it's any number in the universe except for these two, because these two create a problem. They create a denominator of 0, which will crash your function and create an error. Go ahead and take your calculator and divide anything by 0, you will get an error. Okay, how about this next one here? Is there any chance of a 0 denominator? Well, there is a denominator, so there's a chance. Is there any chance of a negative in the square root? Well, there's no square root, so there's no chance of that. So let's just see if there's a 0 denominator. Okay. Well, we're going to set this equal to 0 and solve. Now, the only way we know how to solve something like this is by factoring. That's the only way we learned how to solve a third power function. So let's see if we can factor this. There's definitely a GCF here. So let me take out the GCF. That leaves me with x squared minus 2x minus 15, right? Because that would give you that. And this is still factorable. So to get the fully factored form, we need to factor again. And this looks like a reverse FOIL will do the trick. Put in x. Factors of negative 15, that would give you negative 2, would be negative 5 and positive 3. So we have a factor times a factor times a factor equals 0. We can use a 0 product rule. So we get 3 answers here. X equals 0, x equals positive 5, and x equals negative 3 from here, right? What's our domain? Our domain is all real numbers except these things. So how do we say except? not equal to, not equal to, not equal to. And that's our domain there. All right, how about this last one here? Is there any chance of a zero denominator? Well, there is a denominator, so there is a chance. Is there a chance of a negative inside of a square root? Well, there is a square root, so that we also have that to worry about. We have two things to check for here. So how do you check the denominator? You set it equal to 0. So we'll do that over here. X squared minus 2x equal to 0. We're going to do that. How do you check the square root or find the domain of a square root? Well, we've been doing that for every lesson since, last week. So how do we do that? We set this part greater than or equal to 0. So hopefully you see the difference here. 2x minus 10 greater than or equal to 0, whereas this was just simply equal to 0. This is for the denominator, and this is for the square root. Let's do both. To this one, we need to solve. Well, it's got a GCF, so let's factor out the GCF. And then you can see we can use a zero product rule for this. So we get two numbers, x equals 0 and x equals negative 2. Both of these will create a zero denominator. And so they cannot be part of our domain. We have to, all real numbers except these so far. But what about the square root part? The square root part only exists if this is true. So what we do here, like we've been doing, like we did in the lesson above with the inequalities, we solve this, right? And I'm getting x has to be greater than or equal to positive 5. Now we combine these two together. Now you could write all real numbers such that x is greater than or equal to negative 5, comma, x is not equal to 0, comma, x is not equal to negative 2, but that's not totally right. And the reason why it's not totally right is a little bit of common sense, hopefully. Take a minute and think about your answer for a second. Here's 0, here's 2, here's 5. This part of the domain says that x has to be greater than or equal to positive 5. So close circle, shade to the right. We've learned this, right? That's x is greater than or equal to 5. We have to satisfy this. We also can't be 0 and we can't be 2. Well, if we're only greater than 5, we're already not worried about 0 and 2 because we're greater than 5 already. So we don't need these. They're extraneous or they're redundant. You see what I'm saying? So really, we only have to write this. And the reason we only need to write this because these are already covered by this. Now, let's say for argument's sake, just for argument's sake, that we had, I don't know, x is equal to, we got from this x is equal to 10, for instance. And 10 would be over here. Well, then we'd have to exclude 10. So we would have comma x is not equal to 10 here. That would be required because everything greater than 5 could equal 10 and you need to remove the 10. But since the 0 and the 2, right, there's no chance of them being on this side here, we don't have to worry about it. Oops, didn't have to do all that. But you get the point, okay? All right, so our domain is x is greater than or equal to 5. We're done. See you at the next video.
Check this.